Hi, I'm Martin Bell. Welcome to the channel. Today we'll be working with Shiny for Python. This is a new web framework that came out a few months ago that allows you to build interactive web applications without the need of knowing JavaScript. So it's similar to Streamlit and Dash, but there are a few differences that I think make it easier to learn, and they make it easier to build more complex web applications. We'll be developing a finance application. I'll be using the code that I developed in the quantitative finance videos. So we already have some code that we can use for this. And the idea is to grab that static code and make it an application. So let's get started. Okay, so this is the application. Basically, we have an input here that we can change the stock that we want. Let's say we want Netflix, and that changes this performance metric, and we get Netflix added to this scatter plot. So this plot is done with Plotly, so you can just filter it as you would normally. Conceptually, these metrics, they tell you annualized returns. They tell you how much money you would make each year. The risk is the volatility of a stock. Max drawdown is the maximum drop from the highest value to the lowest value that this stock experience, and the Sharpe ratio is division between the returns and the risk. It takes into account the risk-free rate. You can think of it as returns divided by risk. It's a way of putting these two values in one ratio. Generally, what you would want in stocks is stocks that are on this area where I have the pointer, that have high returns and low risk. So let's take a look at how we can build these applications. Here I'm importing a few libraries. So then I have a function that, given some returns, it computes this table here. In the next video, I'll break this down into multiple steps. But if you think of it, this is kind of like a mini script that you have as input returns. That's basically percent changes of a stock. And here we do a bunch of calculations, and we get to this summary that has the annualized returns, the annualized risk, and the max drawdown, and we return that. So this is what the performance function does. And there are a lot of libraries in Python to do this, but you can just do it with pandas. And actually, pandas makes this type of calculations very easy. The next step is the UI. So this is what defines how we will show the result. We have a row. A row would be this part here where I define the input. So look at this UI.inputSelect. We call it stocks, and this is what we'll show to the user. So internally, we will be able to access this list of stocks using input.stocks. So let me show you here. So input.stocks. Then we have the second row here where we define how we show the outputs. In the first one, I have the performance report. Here we are showing it. It's literally a table. And the second one is the Plotly graph. That's this output widget. And this is really all you need to do to define how you will show these plots, tables, or inputs. But you can actually leave this for later if you wanted to. I mean, it doesn't have to be done at the start. You can just start with just putting the outputs one below the other and then start rearranging them. So then comes the server, and it works as the backend. The idea is that here you define how these elements talk to each other. How if you change, let's say I change this stock, okay, how these elements are computed. In Shiny, we have the idea of reactive programming. So for example, here I pass this decorator reactive.calc, then I define a function. So the next time I call this function, it will run what's inside here. But we don't need to run all the application from start to finish if I want to change something here. The difference with Shiny and other frameworks is that they run the entire script each time you change something. And in Shiny, you just run what you need given an input change. So if I change a stock here, this is what connects this slider. You just change this and this gets updated. And you can further break this down into multiple reactive calculations. And that's what I'll be showing in the next app, how we can refactor this code to make it more, more modular. So each calculation is done separately and you can access the elements of each. Let me show you what's happening here. So you get a list of stocks, then here we are selecting the stocks and computing the percent change. That's basically the returns. And so far the data, the raw data is daily. So in order to do analysis, it's better to convert it to monthly. So then I'm doing this, I'm resampling the data to monthly frequency, and then I'm computing the returns at the monthly level. So this is what's happening here. Basically, what I'm doing is 1 plus the return of each day, multiplied 1 plus the return on another day, and so on. So to compute the return of a month, you need to do 1 plus the return of each day. So then I have a few filter dates here that I would like to build an input to control the dates. And that's what I'll be showing in the next video also. So here I'm filtering the dates and filtering the data using start and end date. So here I'm filtering the df.selection data frame using the start and end date. And then I'm calling the performance function. So that's what I show you above. And this is basically what computes this performance report. And yeah, the final step is computing an equal weight portfolio. So if I would invest the same percent on each stock, how would that work? So that's kind of the simplest portfolio you can make, and it's done here. The way it works is you just take the average of the returns of each stock, and that's it. So that's what I'm doing here. Next comes the render table. So basically what I've just shown you is something that's happening internally. We didn't show it yet. So in order to output it to the front end, we need to use this decorator. We use decorator output and then decorator render table. So what this means is that this function will become a table. So here I'm doing a small reshaping of these results, and I return it with this function. So if you look at this name, performance report, that's what I'm using here when I'm linking to it in the UI. So the same happens with the plotly graph. Here it's called scatter plot, and we have the output widget scatter plot. So basically these are the two outputs of this application. If you think about it, I mean, this looks not very different to what you would do in a notebook. Let's look at the scatter plot. So here I call this compute returns function, have it here also. So this is the reactive function. So if something changes, this function gets run. So if you look above, what it means, it's the one that's doing all the calculations, right? So then I do some reshaping of this. The next code, it's literally what you would do in a notebook. So this is just a scatter plot with plotly express. So I pass the data frame, x-axis analyze returns, y-axis risk, and just pass the text column with the ticker. This is just to control the axis. So it prints what we want. One thing that's Shiny related is this call that you need to do go.figure widget, and I think this is what allows you to convert the figure to something that we can show in Shiny. So let's do another final walkthrough of the app. So we first have some imports, then we have a function called performance that does some calculations, and so then I'm reading the price data. So I have it in a Parquet file. You could just, if you deploy this in production, you could just update this file every day. And then here I define the UI. This is the first row, so the tickers. And this is the second row that has the performance report and the risk and return plot. And then we have the backend. So the backend has one reactive calculation generally you would have a lot of these reactive calculations, but I wanted to use a very simple example. So this is where you would start working with this data that you read globally in the application, and you would make some calculations. So here we are selecting some stocks, computing daily returns, resampling to monthly frequency, and then filtering start and end dates. Then we have this performance report, that's what we are outputting. And finally, I have this scatter plot, and this is another output. So this is basically just getting the data with compute returns, doing some reshaping, and then plotting with Plotly Express. And yeah, finally you need this line that basically combines all the elements, the UI, the server, and this is optional. You can try using false and true. So how do you run this in VSCode? So there's an extension that you can install that basically adds a button here. The play just basically runs the application. I mean, I tried it, it worked for some time, and then I don't know why it stopped working. So I had to run it manually. But basically how you would do this in with Anaconda, that I assume most people use for data science, is you first activate the environment you're working with. So conda activate tabular. In my case, that's how it would work. And then you have this command, basically shiny run, and you pass a reload argument and then the file name. So let me show you how this looks like. It's starting to run in localhost port 8000. So I already have this browser here that you can open from VSCode. And if I refresh it, it will start again. So yeah, there it's starting, and it will be printing some things here. Let me show you one thing. What happens if I remove a parenthesis here? So just remove the parenthesis, so we have an error here. And yeah, Shiny is telling me, hey, you have some syntax error. So it's in line 152, something's going on. So okay, I'll just add it back. Click Ctrl S for saving, and it reloads the application automatically. This is very handy because you can continue working on the application, and you don't have to stop it and start it again. So it continues running. Yeah, so that's basically all this application is doing. I mean, it's still very simple, and I mean, for what we've done here, it's something you could do with Streamlit or Dash. But as I continue adding more logic to it, make it more complex, I think it will be very clear the advantage of using Shiny. Okay, that's it for today. Please subscribe and like the video.